Professor Shan will share with us on the topic, the power of analytics, so that we can know more about how we can make decisions with analytics of data. This seminar will be conducted in English, supplemented with Mandarin. 今天大师班会以英语辅以普通话进行，题目是运筹帷幄，优化世界。We will have a Q&A session at the end of this seminar. You are welcome to type your questions in the Q&A box to ask Professor Shan. Questions in English and Mandarin are welcomed. I guess you can't wait more to hear from Professor Shan. Professor Shan, please.
Thank you, host. Can you hear me okay? Okay, so if you can hear me well, I will give a lecture. So the host introduced me as the Vice President for Research. But first and foremost, I'm a professor. I've been looking forward to give this lecture. In fact, when I was a professor at UC Berkeley, I used to give this lecture all the time. Actually, we have the outreach activities to high schools. So I will be giving similar lectures to many high schoolers in the Bay Area. So today, finally, I got my chance to give a similar lecture to high schoolers in Hong Kong. So I wouldn't call this a lecture because it's really a sharing of my own experience working with real companies, real agencies, how to solve real problems. So I do welcome your questions, your comments in the end. But before that, let me just briefly talk about what is analytics, right? So let me give you a good example, a small example. Now you are growing up, you're about to go to college, and then you need to learn how to cook. And then your mom will tell you, look, you need to eat some rice, bread, but also veggie is really important. And sometimes she also asks you to eat some fish, meat, right? So you probably are learning how to cook a good meal. Well, normally, I assume you know how to cook already, but if you don't know, I'm teaching you right now. So basically, if you want to have rice with veggie and meat, what do you need to do? You need to wash the rice, wash the veggies, cut the meal, and then cook the rice and stir fry the veggie and meat, right? Sounds simple enough, right? But my question for you is that actually, how do you do this as quickly as possible? Because you don't have much time. You need to go to classes, you need to play basketball. So what is the best way to finish this order from your mom as soon as possible, right? So I will give you a few seconds to think about this. But before that, let me just ask you to think about in all these different tasks, is any of the tasks can be done parallel? That will really help you to save the time. Okay, so if you are like me, who are really organized, I probably will do this, right? I will prepare everything and get ready for this big task. So I will wash my veggies, cut the meat, wash the rice, cook the rice. When the rice is ready, I'll cook my meat because I don't want veggie to be cold while I eat my meal. Right, this sounds good, right? But this is not the most efficient way. I can tell you a method that can cook the whole meal in much shorter time. Okay, so for example, what if you do rice first, right? So you cook the rice and then you cook the dish. Or you cook the dish first and then you cook the rice. But the key point, what is the key point? I'm not sure you're allowed to give me an answer verbally, but the key is that the rice cooker can actually cook rice automatically. So you don't have to spend your time cook the rice while waiting the rice to get ready, right? You don't have to waste your time there. With this in mind, actually, can you quickly check which method is the most efficient one? It's a simple math, right? If you do some calculation, you'll find out that actually this method will give you, the second method will give you the least time. because while you are cooking rice, in that 15 minutes, you can wash your veggie, cut the meat, and then cook your dish, all within the 15 minutes. So overall, this gives you the shortest time. So this actually was the example that motivated me to study this discipline, because I feel this is really exciting and interesting, right? How do you finish your task using the least time? How do you maximize the gains of your project? Okay, there are many things you can actually put all these different tasks into order and then try to get the best result. So this is actually is a discipline called operational research, or in Cantonese, I don't know Cantonese really well, but I'll try to pronounce it. It's called Wang Chao Hao, okay? Something like that, don't laugh at me. But this is a discipline actually try to use academic tools, analytical methods, such as optimization to improve the decision-making. So the example I give you is shows that if you can use the method better, you can minimize the time you need to finish cooking, okay? I can give you many other examples. But before that, let me formally introduce you the concept of optimization. It's the action of making the best or most effective use of a situation or resource. I came to Hong Kong last year and then immediately fell in love with hiking, right? Because this is probably the best place in the world to do hiking. And if you do hiking, you probably know that you need to have a knapsack. You need to carry some stuff. You need to carry water, some energy bar, some medicine to expel mosquitoes, things like that, right? But you don't want to carry too much, right? Nobody wants to go hiking and carry 100 kilograms of stuff, right? So suppose we have an objective of carrying something, but not as heavy as 15 kilograms. So you need to choose many things. And your mom also probably send you something for you to carry, but you have to make a choice, right? I don't want to carry too many. How do you do? How do you pick the few items so that it maximizes your utility? Utility means something you really need. If you get hungry, you have energy bar. You certainly need water. Nobody can go hiking in Hong Kong without water in the summer. You certainly need, so those are the things you need to pick. But how do you pick them to maximize your utility while not exceeding 15 kilograms, right? Another example we constantly run into is that the shortest path problem. How do you go from A to B, use the shortest time, right? If you ever sit in a car or if you ever drive, you will know that now we cannot live without GPS system. Whenever you put in your destination, the GPS system will tell you, look, you need to go A and B and C so that the time you spend is shortest. All these are good examples of operational research. So I won't teach you math today, don't worry. But roughly, what we are doing is we try to put all this in a mathematical model, right? The model, basically your utility can be represented by fx, and x is your decision variable, right? Basically for the knapsack problem, x means which item you want to pick, right? And then with that, you try to come up with a utility function, objective function, and then you try to maximize your utility, right? By picking the solution that gives you the maximum amount of utility, right? So this sounds to be really simple, but in real life, what makes it complicated is that you need to know your objective function. Sometimes you don't even know your objective function, right? Cooking a dish is easy, but when you try to go to college, there are many things you need to consider, right? You want to start what major you want to study, what career you want to have, what kind of fun you want to have. All these are, you can build all these into your objective function. And then you have a feasible region because there are only some things you can choose from. You don't have unlimited options. So given the feasible region, you need to pick the action that will maximize your whole objective. So this is basically operational research and optimization, right? So come back to this knapsack problem. I trust me, this is the only mathematical formula I'll show you today. So bear with me, right? So here is very easy, right? So suppose you want to pick this green box. It might be an energy bar. The utility to you, suppose, is 4, right? And the weight of this energy bar is 12. Okay, it's quite heavy. A lot of good chocolate food in it. So if you pick this green box, you have 4 utility, but then it also costs you 12 in your weight. And if you pick the blue one, the utility is 2. Maybe it's water. It's less heavy, so you only add 2 to your constraint. And then, so you need to suppose you have 5 items to choose from. Eventually, you can solve this problem. You want to maximize your utility, right? That's the objective function, 4x1 plus 2x2 and so on. And your feasible region is that all this add up, the weight cannot be more than 15 kilograms. And x equal to 1 means you will pick this item. x2 equal to 0 meaning you will not pick this item. So 1 meaning you pick it, 0 means you don't pick it. And you can easily solve this problem using the software in many commercial softwares, right? So this is a simple example, but the later example I'll show you will be much more complicated. I can give you many examples here. In fact, after I studied this discipline, I've been working with all kinds of industry, retail, healthcare, transportation, finance. So in retail, I hope everybody heard the term logistic and supply chain. And then this is what we've been busy working with. How do you make the product and deliver to the customer using the least cost and least time, right? This is called supply chain management. And during COVID situation, the whole world has been experiencing supply chain issues. In America, when COVID broke out, there's many empty shelves. Well, even in Hong Kong now, we still have some, right? So this is the problem of not being able to optimize your supply chain. So we need tools to do this better. Why we have this empty shelf? Because there's a difference in supply and demand. If your demand is higher than supply, of course you will have empty shelf. But on the other hand, if your supply is much more than the demand, then you will have too much inventory, and then you will also lose money. So it's a complex problem. In healthcare, I've been working with hospitals, health agencies, try to figure out the most efficient way to treat patients. If in the hospital, if using operation research, if you can increase the number of patients you can treat, you will save more lives. So this is really important. Transportation, I've been working with Department of Transportation, try to minimize the congestion on the highway. Right? This is also very important. How do you make sure, well, sometimes you cannot make sure, but how do you minimize the congestion level so that everybody will spend less time in the traffic? Finance, actually many people will probably end up take finance as a major in college. And then in Hong Kong, we do have a really top-notch finance program. So here the decision that which stock you should invest to maximize your wealth, right? So this is also a decision-making problem. So let me give you 2 examples that I worked with, and the first one is with Alibaba, which own one of the largest logistic system. And I will show you how I work with them to make the system more efficient. But here, just before I talk about the solution, let's think about the complexity of the problem. Because every day they deliver about 64 million packages. Okay, 64 million. That's a lot of packages. And this is also growing at a really fast speed. And then, there are many different logistic lines that is being used by Alibaba to deliver products. And they deliver to more than 220 countries. But the objective here is not simply just deliver. Well, you need to deliver everything in China within 24 hours. And then they also have an objective of deliver everything globally in 3 days. 64 million packages delivered in 72 hours. If you just think about this, it probably will drive you crazy. This is why they formed a ET lab. So I was the director for the ET lab because we believe this is a problem can only be solved by ET. It's so complicated, right? How can you solve this problem? Even nowadays, I think I order something for food online. It takes them more than 3 days to deliver, even in Hong Kong, right? So how do you achieve this objective? Well, it's really complicated. I can give you a lecture on this alone as a class for the whole semester. But let me make it really simple because think about this. To deliver all these products within a certain times, you need warehouses because without warehouses, if you deliver from the manufacturer to the customer, this alone will take more than 3 days sometimes. Right? For example, if the manufacturer is in Europe, if you just purely make it and then ship to Hong Kong, it will take more than 3 days. So what are the solutions? You got to build a warehouse in Shenzhen or Hong Kong or somewhere nearby. Then when we order from Hong Kong, we can deliver from this warehouse, right? So the first question actually we try to solve is that how do you come up with this warehouse location? Where should you put those warehouses? How many warehouses you should build? And what should be the capacity of the warehouse? Okay, well, if that problem is being solved, then you will have the inbound logistic problem. Basically, now the problem is that how do you ship all these products to the warehouse most efficiently? So roughly 3 steps. First, we need to design the warehouse. How big, what are the equipment you got to use? I'm not sure any of you have been to a warehouse, but it's fascinating to see how the big warehouse operate very efficiently. I've been to the Amazon warehouse in California. The warehouse was huge. You cannot see the end of the warehouse. It's so huge. And then you have thousands of workers working at the same time. And then, if you customer order something, will take them less than half an hour to pick it from the warehouse and then put it in the package. So those are the 3 things I mentioned here: storage, material handling, and order picking, right? So this means that you get the item from the warehouse. The next step will be how do you ship it from the warehouse to the customer, right? But before that, let me show you an interesting video that shows how complex this can be. Okay, so those are the problems we've been solving. You probably have no idea what this means, but let me show you a video that shows how this can be done. Okay.
Kiva uses a breakthrough new approach to order fulfillment, one that simultaneously improves productivity, speed, accuracy, and flexibility. With the Kiva mobile fulfillment system, the operator stands still, and products, cases, items, or orders come to them. Pallets, cases, and orders are stored on inventory pods that are picked up and moved by a fleet of mobile robotic drive units. The distribution center is now completely dynamic, self-organizing, and self-adaptive. The first step is restocking. A pallet of products arrives in the building and must be put away in the picking area. With a typical solution, the worker must find out where the location of each of these cases is in the distribution center and wander out into the warehouse to manually place them back into their racks. But with Kiva, when the worker scans the inventory for replenishment into the system, the drive units immediately begin moving to bring the correct pod for replenishment. The worker will not move from this spot to replenish all of these cases. By eliminating operator travel, Kiva increases productivity. In addition, since the system dynamically calculates the optimal location for replenishing the product, Kiva eliminates the need to analyze and reslot inventory. Once the inventory is in the system, workers can pick items to fill customer orders. Part of the Kiva mobile fulfillment system is a server that is integrated with the customer's warehouse management system. This server receives the customer order and assigns it to a picker at a station. These orders will be filled in real time, unlike other systems that require batching orders together before they can be filled. As soon as the order is assigned, drive units are dispatched to retrieve the inventory required. Each worker is supported by 5 to 10 drive units that will line up and wait their turn to be picked. The worker stays in one place and lets the work come to them. As a result, each worker can produce 2 to 3 times as many orders per hour. The first pod to arrive is the shipping pod. This pod holds the box that will be shipped to the customer. Each pod has several orders on it, which means that the pick worker is filling several orders simultaneously. After the shipping pods arrive, inventory pods arrive, and a laser pointer illuminates the item to be picked. Because of this very simple user interface, the Kiva system requires little or no operator training. The worker picks the item and scans the barcode to confirm it is the right item. If it is correct, a light will come on to tell the worker which order to place the item into. This scan is one reason that quality with the Kiva system is higher than other solutions. Every item is checked by the picker. After the worker places the item, they press a light to confirm they are done, and then they turn to pick another item. By the time they turn around, a new pod has arrived and a new item is ready to be picked. After the item has been picked, the drive unit returns the pod to storage. The location it goes to depends on the item. Fast-moving items are stored near the workers, while slow-moving items are stored further away. And the storage location is adaptive, not permanent. As the speed of the item changes, the location will change. Once all of the orders on a shipping pod are complete, that pod leaves and is replaced by another empty pod. The completed orders are now ready to move to the shipping door and be loaded on a truck. As soon as the dock door is ready, the shipping worker indicates which truck they are loading, and all of the appropriate orders are retrieved. The worker unloads each box from the pod, tapes it shut, and loads it onto.
Okay, hopefully with this short video, you learned how the workers put the item from the warehouse on the truck. In fact, let me tell you a little bit more background story of Kiva. Kiva was invented not long ago, about 10 years ago. And the robotic unit was invented by an MIT professor, by mechanical engineering. The whole system was designed and optimized by many disciplines: industrial engineering, mechanical engineering, business school, computer science. So the system was built, even though only 10 years ago, but it was bought by Amazon, $8.3 billion valuation. So it shows that even in this very old industry, there are still opportunities to renovate, come up with better products, and make money. And nowadays, logistics is really the most popular industry in many countries. So I do think if you can tell from the video, there are many things that you can optimize. Amazon have 200 PhDs working in these warehouses, trying to improve the efficiency. If you can shorten the delivery time by just a few minutes, it can save you a lot of cost, right? So I will give you another example later, but this shows that if you can optimize the system efficiency, you can improve the efficiency and then you can save cost. And then, so after you put your item on the truck, then you will do the outbound logistics. Outbound means it's out of the warehouse being delivered to the customer, right? So most of the time, you will have a big truck delivered to a smaller warehouse. And then from the smaller warehouse, you will do the last mile delivery. And then the last mile delivery, you normally will have a delivery man to carry the item, send to your flats. This is called last mile delivery. I also want to show you that there are a lot of innovation, innovative solutions in this domain. And then, in fact, China is leading in this domain. There are many smart ideas being invented, and then many of them became really successful companies recently. So there are a lot of things we can also learn from this industry. So let me show you the next video where it shows that the last mile delivery problem, it actually is a very complex problem, right? Because you need to deliver millions of packages to individual customers in a very short time. How do you do that?
What is the most efficient way to deliver 16 million packages a day? That's the problem that Jack Levis and his team at UPS are trying to solve. To understand what they're up against, let's pretend I have an Aunt Gertie and I want to send a package to her. Its journey begins in San Francisco, Tuesday night at 8 p.m. By 2 a.m. Wednesday morning, it lands in Philadelphia, only 140 miles from Aunt Gertie. 7 a.m., it arrives here at the UPS shipping center in Gettysburg, Pennsylvania. It's already traveled over 2,500 miles in less than 12 hours. It would seem like the hard part's done. But as I found out, it's just the beginning. Once it's on the truck, figuring out the fastest way to get it the final 4 miles to Aunt Gertie's, that's the real challenge. To do that, you have to solve a very difficult and complex math problem.
Traveling salesman problem.
Traveling salesman problem?
The traveling salesman problem.
What's that?
It poses the question of what's the most efficient way to visit locations, just like a traveling salesman used to have to figure out.
Simple, right? Turns out that this problem has vexed generations of mathematicians.
Let's say you have an office on Main Street and you have 3 customers. One's on Elm, one's on High, and one's on Maple. You know the time and distance between them. Well, what's the most efficient way to visit these customers?
So Elm, High, Maple, that's 1. Maple, High, Elm, that's 2. High, Elm, Maple, 3. High, Maple, Elm, 4.
Well, there's 6. You know how I know there's 6? With 3 customers, it's 3 times 2 times 1. There's 6 ways. If you double that to 6 customers, now there's 720 ways. At 12 customers, there's 479 million ways. If you had 25 locations to go through, there's 15.5 trillion different ways to visit 25 locations.
Trillion? So if a 25-stop route has trillions and trillions of possible combinations, imagine how many possibilities there are in the 140-stop route that will take my package to Aunt Gertie.
There's not even a number to articulate this. There's more ways to deliver this route than the number of nanoseconds the Earth has been in existence.
So if the traveling salesman problem is too tough for the world's largest computer, how do you solve it? By building a smarter program. It's called Orion. How does it actually calculate the route?
Well, it's going to start with something that's just very simplistic. It's not going to think like you thinking ahead. It's going to say, who's my nearest neighbor? So it's going to start at the beginning. What's closest to me? And I go to the next stop closest. So when it's done in its very first iteration, it's created a route that looks like a kindergartner would have created. And then it says, now what's wrong with that?
In this case, it does that by breaking the task down into sets of smaller problems, each with 5 variables with 120 possible solutions. The first step is starting with clusters of 5 stops and figuring out the most efficient way to deliver packages within that cluster. It arranges them into larger groups of 5 and figures out the most efficient way to move between them. Finally, it connects them all together and arrives at a solution with only thousands of calculations total. And it does all this in a few seconds. But that's just the start.
Okay, so this example shows that, to deliver the packages to the final customers is a really complex problem. Not only is complex, but also it takes a longer time, a really long time to solve the problem. You cannot let the delivery man to wait for 2 hours to calculate the solution, right? So you got to come up with a solution that is good and very fast. So this is a subject that we've been working on for a long time. So with that in mind, with all these solutions put together, Alibaba actually configured this powerful engine to deliver products to millions of customers using fast record speed, right? So I don't have time to go into all these details, but if you are involved in my lectures in the future, I probably will teach you all these different modules. All these modules together will come up with a mathematical model and then computer code to deliver a reliable and efficient solutions. And these solutions in the video I show you assume that everything goes smoothly, or there might be some disruptions in the supply chain. There might be some route congestion, but you still need to deliver most of the packages on time. So all this need a good mathematical tools to help you to solve this problem. So if you come to Hong Kong U, we'll teach you this modules separately. Okay, so I've mentioned one example which shows that the world is really complex, but we need to figure out better solutions. So let me give you some other updates about analytics. You probably have heard that almost every university, every country has been investing heavily in data science and AI. So MIT have this new institute for data, system, and society. They have invested $1 billion about this. UC Berkeley, where I came from, have now a college of the data. Basically, it became similar to a college of engineering and college of science. Now they have a college of data. And here at Hong Kong U, we also set up the first institute of data science. And then this institute was possible because of generous donation from Musketeers Foundation. Well, let me quickly bring you to this website. Hopefully can you see the website? So basically we are recruiting heavily the top scientists from the whole world, try to tackle a lot of problems in AI and big data. So the objective is to use data to solve many of the societal problems. So if you have a chance, you can go to datascience.hongkongu.hk, try to figure out more details about this institute. So what we try to do here is that we don't just try to chase the waves, right? Everybody knows AlphaGo, which became a really successful story that the computer, the AI, can beat the smartest chess player. But AlphaGo only works in a limited space, and you have well-written rules. In real life, the rules are not well-written, and the situation keeps on changing. So the future of AI is really basically, we are looking for a more intelligent solution, less artificial, right? So this is what we try to do in this Institute of Data Science in Hong Kong U. We try to assemble a team, look at the real problems in our society, and then try to come up with a sensible and reliable solution, okay? But let me just give you a quick introduction of analytics. So basically, it's a systematic way, in fact, more on the computational side of data. So there are all the different terms you have heard some of them. There are descriptive analytics, diagnostic analytics, and predictive and prescriptive analytics, all different names. But they are all useful because descriptive means you want to analyze what happened. After that, you want to figure out why did it happen? Diagnostic, right? Then predictive means that what will happen next, right? After you figure out what happened in the past, you need to forecast the future. And then with all this forecasting, you need to tell people what to do next, right? All these are really important. So to do all this successfully, you have to have a lot of data. This is why we call it big data, data science. But the data have to be reliable, and you have to keep on collecting reliable and real-time data. And then you need to manage all this data efficiently, because the data, if you want to collect data, the amount of data can be huge, and then you need to figure out better ways to storage, compute all this data, and eventually come up with a solution. So again, I want to give you an example that I've been working with e-commerce company, try to come up with real-time decision-making to satisfy the customer's needs, right? And all this was driven by real-time data, okay? So with all this data you have collected so far, forecasting is really important, right? So who can tell me the weather tomorrow? well, we already have a lot of complex and fancy algorithms, but still we make mistakes, right? But then for e-commerce platform, if you want to forecast the sales of iPhone 13, for example, how do you do this, right? And people have different methods to do this, but the rule of thumb is that no forecasting is correct. If there's somebody who can correctly forecast everything, then this person will not exist. It will be rich any second. So you will make mistakes. Even though you have a lot of data, you will make mistakes. But how do you make decisions based on this not perfect forecast, right? So machine learning comes into play because you need to basically look at the historical data and try to learn from the data. The learning can be imperfect, but we are gaining information. We are learning like a baby, and gradually you will get better and better at this. So let me give you just an example of an e-commerce platform, right? For example, I've been working with a lot of e-platform companies. The key question is that how do you order the right amount of products for your customer, right? I mentioned iPhone 13, but if you are Amazon, how many iPhone 13 you should keep in your warehouse, right? If you order too many, you cannot sell this, then you incur a loss in the end of the season, or if you sell this next year, you have to sell this at a discount price. But if you order too little, then you won't be able to make enough money, right? So traditionally in the literature, people always do this two-stage approach. They will do a really good forecast. In fact, Amazon have a strong team doing forecasting alone. And then they come up with a lot of fancy methods. But again, any forecast will not be perfect, right? So based on this imperfect forecast, they come up with the inventory ordering decisions, right? How many you should order. But Amazon doesn't hold just iPhone 13. They have hundreds of millions of different products, right? So how do you do this well will decide whether you are the most profit-making company or not. So in fact, I will introduce a new method that my research team came up with. And this method is basically data-driven and use machine learning. We call it end-to-end machine learning method. And it's being used by a giant e-commerce player, and it has been really successful. So I want to show you that in our discipline, if you work closely with a company, you can actually help them do things much more efficiently. Okay, so let me see, I probably need to quickly wrap up this example, but just think about your daily examples, right? If your family own a fruit shop, for example, summer is coming, you probably need to order watermelon every day. But all these fruits are perishable, right? You don't want to order too many, and then if you cannot sell them, you incur a cost. Once again, as I mentioned earlier, if you don't have enough, then you will incur another cost. So this is basically the inventory management problem. That how do you decide how much you want to order from your supplier so that you make the most money, right? So this is called the inventory management problem. In Walmart, in fact, when I teach supply chain management, I always use Walmart as a really good example. Walmart in the 1980s, even early 1990s, was not the largest retailer, not even in US. They were probably number 5, number 6. There were Sears, there were Kmart. Both of them are bigger than Walmart. So how did they become the number 1 retailer in the whole world, right? Because they are using inventory management to perfection, right? I can't give you a really detailed answer, but in summary, they have been using optimization to help them reduce the inventory waste and the inventory shortage so that they can afford to sell their products 10 cents cheaper than their competitor, right? So in America, people don't go shopping every day like what we do here, especially for grocery. People just go to the supermarket to buy once a week, sometimes once every 2 weeks. So we'll go to Walmart or another retailer and then buy a whole truckload supply. So if every item saves you 10 cents, 15 cents, overall it saves you a lot of money. So this is why they were able to attract all the customers to go to Walmart, because it did save the customers a lot of money, right? So I use this Walmart example in my teaching, and then I eventually worked with another retailer, try to get them help to help them get better. So actually the retailer is called JD.com. Now is already the largest retailer in China and the third largest internet company globally. They have right now more than 500 million active customers. And then again, they want to deliver everything within 24 hours. If you live in major cities in China, Beijing, Shanghai, you order your product in the morning, you get it in the afternoon. Okay, so this is what they can do. But again, with so many customers and so many orders every day, how do you do this? How do you deliver all these things within 24 hours? In fact, in most of the cities, it's within 8 hours or 4 hours, right? So when we first look at this problem, it looks very complicated because all the products have different features. There are some fast-going products you put on the shelf, it will be gone very quickly. There are some long-tail products, meaning you put there, not many people want to buy them, but you still want to keep them because the success of an e-retailer is that you will own everything. So that people come here, one-stop shopping, they will get everything, right? So they also need to keep all those long-tail products. And then there are many products that are sensitive to promotions. So if you reduce the price, the demand will pick up very quickly. With all these, different categories in mind, to manage the inventory for all the different categories is really difficult. And then in JD.com, there used to be this analyst who can manage maybe up to 200 products. That's already a lot if you think about this, right? If this person can manage iPhone 13, manage it, I mean, you have to do the forecasting of the demand. You have to know how much to order from Apple. You have to decide where to put them, which warehouse, how many in each warehouse. And then you need to arrange transportation to deliver to the customer. This is a lot of work. To manage 200 SKUs. SKU means stock keeping units. Basically, it means distinct products. For example, a white iPhone can be different from a black iPhone. So they're treated as two different products because somebody only wants white iPhone, not black iPhone. So if you can manage 200 SKUs, that's already a lot. Many people cannot do this. And if you have 300 million different SKUs, how many people you need to hire, right? If you do this math, you will figure out that's impossible. You need millions of people to do this. So what happened is that they cannot afford to hire this many people. They will just manage the top 10% or top 20% of the products. There are many products are not well managed. This is why they have so much inventory in the system. Okay, and all those inventory will be converted into waste and then the money. So the consumer eventually will have to bear the cost, or the retailer will have to do something about it, right? So how do you help them do things more efficiently? How do you come up with a system that can help JD.com to manage hundreds of millions of different SKUs more efficiently? So basically, with all these constraints, deliver on time, save cost, you basically think that this is impossible to only use people to do this. So we came up with an AI system, actually. The AI system can actually learn in the big data environment all this past historical data, and then to try to come up with a solution. You probably heard this the similar story that if you have a refrigerator in your house, the refrigerator can order milk or bread for you because sometimes you are too busy to even check your inventory. And if the refrigerator can see the reducing of the milk level, when the milk is reduced to a certain level, then the refrigerator can call or email the supplier to deliver milk to you. So this is a similar concept. In fact, the only difference that we are managing hundreds of millions of different SKUs. So to do this, actually, we have to study all this data. The data on the left side, all the information, the color, the brand, the sales, where it comes from, how long it will take it to ship from the supplier to the warehouse. In fact, in JD.com, the warehouse have several layers. There are huge warehouses, like the one in Beijing is huge. And then there are smaller and smaller warehouses, right? So they have to go through this chain of warehouses before they can deliver to you. With all this information, my algorithm, my AI system, can actually figure out automatically the right order amount for each different products. So this is the core of my algorithm, right? The machine learning algorithms will automatically read the data and then come up with the optimal order quantity. And this research has been already published in Management Science, the top journal in our field. And actually, we also won a top 6 innovation award globally for this innovation. So I don't have time to go into detail of this AI system, but basically with this, actually, it can help a giant e-retailer to plan and manage their inventory efficiently so they can minimize their cost. In the end, it will benefit the consumer because we will pay less, right? So currently, it's already being implemented in JD. In fact, the number is expanding. We are trying to work with as many SKUs as possible. I probably will use another 1 or 2 minutes to wrap up. Okay, so I have talked about 2 examples, but the last example I want to show you is actually really important. I want to show you that actually our research can also help combat COVID-19. So as I mentioned earlier, the supply chains in COVID-19 situation has not been functioning really well. But how do we optimize the supply chain, especially for the vaccine supply chain? How do we deliver the vaccines efficiently? In developed countries, this is not a problem. But now we need to worry about developing countries, especially Africa. If you read the news, you will find out that they don't get timely delivery of vaccines. But to combat COVID-19, this is not, if US or Hong Kong is okay, then we're okay. No, it's a global situation. So we got to optimize the vaccine supply chain globally, right? How do you improve the testing? How do you make sure that we can combat COVID-19 very efficiently? So I wrote a paper about this in Scientific Report. Actually, we come up with a method to do pooled testing, meaning that we don't test individually. We test 10 people, 5 people, 20 people together. Because at the beginning of the pandemic, or before it picked up, the number of people infected is not that many. So you can use this pooled method to save cost and time. And in fact, even this morning, I pick up the news from Hong Kong U. Actually, the top 3 news are about my research. So how our research can help contain COVID-19 very efficiently, right? If you are interested, you can go search this paper. It's published in Scientific Report. So in summary, our method, operational research, can help retail, healthcare, finance, any system, any complex system. As long as they have decisions to make, we can use their data, their rules to come up with better decisions. So I will stop here. I have about 10 minutes left, so I'll welcome any questions or comments.
Okay, thank you very much, Professor Shan, for inspiring sharing. We are now moving to the Q&A session. We have gathered some questions for Professor Shan on Zoom. And the first question is that we know that it seems that the threshold of using big data analysis is quite high. Is that really the case? We see if we are just a small size company, like we are a startup business, how can we learn from Alibaba's story, or how can we leverage the power of analytics, Professor Shan?
That's an excellent question. In fact, we've been thinking about this. If you look at the major companies, they are investing millions of dollars on this. The AI team in Alibaba, Amazon, JD, they have more than 200 people, right? So actually, there are efforts to help smaller business owners to do this too. In fact, I was involved in a startup company in Silicon Valley, try to do the same thing. So basically, if you do the AI decision making, there are major modules. So we can come up with AI for AI or automatic AI, meaning that we come up with modules for you to use. You can put a different face on these engines, but in the end, you don't need to hire 200 people, probably only 2 or 3 people to use the kind of the modules we build up. I think you can easily enter the AI world. Because for AI, algorithm is one thing, but the data is really, really important. If you do own data, if you have some smart people help you analyze the data, then there are companies out there to help you to reduce the barrier to enter this analytics world. So there's hope out there.
Okay, thank you, Professor Shan. Now we invite our audience to unmute themselves to ask questions directly to you, Professor Shan. Our first audience is Jun Ma. Hi, Jun.
Hi. Okay,
yes.
can you hear me?
Hi.
Oh, okay. Hi, Professor Shen. Thanks for your talk, and I think I know a lot from it. Because I am researching the optimization problem in automated warehouses such as Kiva system. So I have a question about the operation in Kiva system, because some study reveals that the Amazon adopts the random method in some processes, such as the replenishment operation. So they think this is a better way than optimization. So how can we understand this phenomenon that the optimization is much better than a stochastic method?
Let me try to understand your question, right? So first of all, this is a really complex system, right? There's no single method dominates all the other methods. I think we need to combine all the different analytical tools to make it more efficient. To give you an example, actually, I have a student, I know a student, graduate from Georgia Tech with a PhD. He worked for Amazon.com. Actually, his job is to follow a few those robotic units and then try to improve their routing. Because in these kind of situations, nobody claims they know the optimal solution, right? So any local improvement you can do to improve the efficiency will be immediately applied to the real system. So I don't think there's any method can say that I'm the best method. You got to combine. In fact, innovation in mechanical engineering is really important. Kiva actually is already outdated. There are more efficient mechanical equipments that can carry more and move faster. And then, in fact, if you look at the video, you'll know that the Kiva system have a lot of limitations, right? They only use legs. There are no arms. It will be perfect if you can imagine there are real people there, can just use a hand to get the product and then deliver to certain locations. But they need a lot of research. In fact, in Berkeley, I talked to a few colleagues who are doing this kind of arms robotics units. I think in the very near future, you will see a totally different system. There you can have better algorithms, better mechanical equipments, and the efficiency will be improved much more. So I think this is a evolution. And then if you can jump into this, if you can help come up with better algorithms, I think that would be a great contribution.
Okay, thank you, Professor Shan. Then we have a next question that is typed on the chat box Q&A. The question is that, does the optimization of productivity eliminate human workers and breed unemployment?
Yes. So, well, there's always a double-edged sword, right? So I think with AI coming into place, there is certainly a reality that many of the warehouses need less people. But so what do we do with this, right? And this is why when you are picking a major, it's really important. Philosophy, psychology, those are the disciplines actually. Now many people think that it's not really helpful with you to land you a tech job. But in the future, if we all have AI running around, you might need philosophy, psychology, humanity to govern the world better. So I think there's always, a trade-off between different technology. But many people see the danger of using too much AI. But some people think that, look, maybe humanity or the jobs of humans can be redefined. We don't have to work so hard in the future. So this is a much bigger problem for me to answer, but I'm not too worried. I think there's improvement, and then we should take on the opportunity, and then we should try to improve on the social well-being of all human beings. So I think this is opportunity. But if you ask me the ultimate future, I can't even imagine, because things are evolving so quickly.
Okay, we have one final question from the floor. The question reads, what is the most important thing for an undergraduate student who wants to pursue our PhD in fields related to OR or OM?
What is the field? What? Sorry, the beginning part.
The fields related to OR or OM, I guess, operational management.
Yeah. So the beginning of the question, what are the
most important things that an undergraduate students need to pursue?
Okay. Yeah. Okay, very good question. Actually, I give advice to my students all the time. So I've trained many PhD students already, and then many of them are professors in top universities. I think the key is the interest. If when I get interested in this area, I have endless energy and I have endless desire to do things better. So you got to get interested in it. And then secondly, you need to work with a real company, because this is really a fascinating world. Without knowing what real company operates, it's hard to come up with a solution to help them. To me, operation research should be a blue-collar discipline, meaning that you need to work with your hands dirty to help industry get better, right? So that's the second important thing, to work with industry. The third is that you also need to know something about computer science, programming, mathematics, because as you can see from the example, the last mile delivery problem. In fact, there's a world record for solving this problem. When I was a student, we can only solve 40,000 nodes to optimality, because this is not easy. How do you verify this is the optimal solution? It's really difficult, because with 40,000 nodes, the number of enumerations is to the order of billions, right? So this alone can be a fascinating field. So hopefully you can also master mathematics well to do deeper research. Okay.
Thank you very much, Professor Shan. And that wraps up our masterclass session today. We'll have Professor Ivan Hung Fan Ngai from the Department of Medicine of HKU to share with us on the topic COVID-19 in Hong Kong at 6:30 in the evening tomorrow as part of our medical series of the Love HK, Love You campaign. Stay tuned. And thank you all for attending the masterclass today. And great thanks to Professor Shan again. Have a nice day.
Thank you. Bye-bye.